Hello, my name's Mark and welcome to RCHacker. Now today we're going to be programming some OpenLRS hardware. This tutorial will cover any OpenLRS hardware. In this case we're going for the RX unit, which can also be programmed as a transmitter as well. What you will need also is some sort of programmer. This is an FTDI programmer. We'll have a closer look at this. This is the preferred method. Failing that, if you're into your multi-rotors, you've probably got a USBasp programmer. You can use this one also. Okay, so moving on, I'm going to switch cameras and we'll get a closer look at these. Okay, so starting out, you want to connect your programmer to your board. Now it's going to be connected onto these pin headers up the top. This is the serial programming headers or serial communications headers. It's handy to have one of these because you can actually let this talk to the computer and do other things like use it as a spectrum analyzer. But that's another topic altogether. Now what you want to look for on here is you want to read the labels off. This is the Hobby King one, and it's very badly labelled. You've got DTR on the right here. The main ones you want to look for is your TXD and RXD. Now you notice those two are on the right hand side here, and then if you look at your focus, if you look at your FTDI programmer, you've also got TX and RX labelled there. So basically you want to connect it such that they will match up together, and that's the way you want to do it. Okay. Now another thing worth noting with these, you do not want to program this at 5 volts. Okay. On board is a voltage regulator, so when you plug 5 volts here from your RC system, that will drop it down to 3.3 volts, which is safe for the HOPE-RF module on the back. If you put any more than 3.3 volts into this, it'll blow it up. The main processor here can handle 3 or 5 volts, so you know, you might, if you connect 5 volts up here or on your ISP header as well, that will provide the full 5 volts to your module on the back, and that'll blow up. Your main chip will probably still work and you'll plug it in and it'll program and all that sort of stuff, but you know, nothing's going to happen. It's not going to transmit anymore. So just be aware, do not program this on 5 volts. Now to make sure you don't do that, on the FTDI programmer, let's see, you can see there 3.3 volts marked there, and on the other side over here it says 5 volts. And then you've got these two jumpers. Okay, so where you connect it, one side, connected on that side, it's going to be 3.3 volts. Make sure it's connected like so. That's your connection. Next thing is you want to plug it into your laptop. You may see some lights flashing, maybe not in the way. This has already got the OpenLRSng firmware on it. Now we'll move back to the computer and have a look at the source code and get the source code as well. Okay, so getting hold of the source code. Basically, Google OpenLRSng, and if it doesn't appear in the top here, I know Google tailors search results, so your result might not look the same, but you want to look for the KH4/OpenLRSng on GitHub. Okay, so click that there. Now GitHub is it's like a big storage system for source code, and it does version control and all sorts of stuff like that. Alright, while you're at it, while you're on the GitHub page, take the time to read the README file. Okay? Well worth a read. It'll tell you all I'm about to say and maybe a little bit more. So take the time to read that. Don't just go for it. You know, you really might learn something. Now what you want to do is just want to click on this zip file here, and it'll download the whole repository onto your hard drive. Okay, so we'll go and put that onto my desktop. and extract it. So you should have a folder called OpenLRSng master. If you open that folder up, you will see the Arduino project. If you haven't installed Arduino, go ahead. There's plenty of tutorials on the internet. This is what Arduino looks like. Really, you should be slightly familiar with Arduino before you get into this, but you know, it's well worth learning. Now, the main thing you need with Arduino projects, the actual directory name that the project is in needs to be the same. So we'll just change that directory name to OpenLRSng like that, and then we can open our project up. So let's maximize that. And so the main configuration options here are all in the OpenLRSng file up here and in the binding file as well. So the OpenLRSng file has got all the configuration options for the particular hardware that you're using. Okay, now pretty much most of the units out there have the same module in them. There are slight differences, and the other binding file has all the options for the actual Hope RF module, and this will change all your frequencies and things like that. Now, the only thing you really might want to mess with here is your default RF power, the first option here. If you're in Germany, you might want to change it to, I think they're limited to 10 milliwatts, so you might want to be a bit sneaky and pick number 4 or number 3, okay? So you just change that there. Just say I was in Germany and I wanted it to be absolutely legal, I'd make it 3 milliwatts. The last setting, 0, 1.3 milliwatts, is also really handy if you're doing testing, and I use that power setting when I was doing my antenna tuning. Also worth noting, I found that if you do change this setting here or any other setting, but particularly the power setting, you need to rebind everything. I'm not sure, I did it once and it didn't seem to increase the power again until I did another rebind, even though I'd reflashed the firmware. Okay, and another setting that's worth noting is the update rate. Now, you've got 3 options here. You've got 4800 BPS for the best range, and I think it's equivalent to like a 10 Hertz update rate, 10 cycles per second. That's for your best range, and you've got medium range, and you've got number 2, which is your fastest update rate of about 50 Hertz, and again, medium range. Now, when I did my testing in my previous video, I had it on this setting here because it was the only setting that did a telemetry backlink, but now I'm pretty sure that Kari has changed it all so the telemetry backlink works for all the update rates, which is great, but it also means I need to go for another bloody walk and test this again. So I prefer the faster update rate because I'm going to be doing FPV with a little quadcopter, so I'm going to set that as 2. Another thing worth noting over here in this file dialog.h, there is actually a command line interface built into this, which means you can plug in your FTDI programmer and then hook it up with, you can probably use the serial monitor in Arduino, or you could use PuTTY or something like that, and there's a whole command line interface for setting this up. So a lot of these settings that I was changing here, you can actually change them here via the command line interface, and then it'll save those to the EEPROM. So I haven't tried this out, and I don't think it's that well documented yet, all this. So worth a look if you want to get into it, but if you just want to get going quickly, make the changes here and then off you go. Then you don't have to worry about changing anything afterwards. Okay, so moving back to the OpenLRSng file and the options there. First one, compilation target. This is where you select where you're compiling for, the transmitter or the receiver. Okay, the default is receiver, so if you leave it like this, it's going to compile for a receiver. And if you delete these two, that will compile for a transmitter. Okay, so I'm gonna start with compiling for the receiver first, and you want to choose your TX board type. Okay, in my case I'm using the same hardware for a TX as I am RX, so I'm going to choose number 3. This is the new OpenLRS NGTX, which Kari, the author of all this, the guru that wrote all this, is building. So he's building this new transmitter module. That'll be pretty exciting. And then you've got the other Flytron modules here. Okay, so we want to select number 3 there, and RX board type, there's only one option at the moment, so you don't have to worry about that. A few other options here. I'm not going to go into these. What else we got? And yeah, that's it. That's basically all you need to know. So once you've chosen your hardware type here and here, all you're going to need to do is either have it compiling as an RX like that, or have it compiling as a TX like that. Like I said, we're going to be first compiling as a TX. Now, first thing you might want to do is just do a verify, make sure it all compiles. Okay, I've got Verbo's output on down here. The main thing you need to see is the binary sketch size and how many kilobytes it is. That'll tell you that it's actually compiled properly. If we go into Arduino preferences and turn off Verbo's compilation, and we'll compile it again, that's good. And that means there's no errors and it's compiled. Okay, I'll switch that back because that's the way I like it, and I'll turn the upload on off for now as well. Now, before you actually program it, you want to select your serial port where your FTDI programmer is plugged into. It should look something like this. Okay, USB serial, something like that. Not a Bluetooth. Just select one of these. Usually it doesn't really matter. I just click that one. And you also want to select your board. Okay. Now in this case you want to select Arduino Pro Mini 5 volt at 16 megahertz. Even though we are programming at 3.3 volts, the MCU is running at 16 megahertz, so we want to select that one. Okay. And now we are ready to program. Go up here and click on the upload button. I do like to leave the Verbo's output on. Okay, at least you know what's going on, then you can see. You should see a whole lot of this gobbledygook here. And when that's all done, it should say verifying however many bytes are flash verified, and AVR do done, thank you. And that's it. You have updated the firmware on your OpenLRS system. Now your other option is to use a USBasp programmer, and same thing, you do not want to put 5 volts in. Typically these will provide 5 volts to whatever they're programming, and they have a little jumper here. Okay, and if that's connected it will provide power, 5 volts, and if it's disconnected like that it will not provide power. There's no option on this one to actually provide 3.3 volts. That said, when you're buying one of these FTDI programmers, make sure you've got one that's got the option between 3.3 volts and 5 volts. Some of them might be just 3.3 volts and some of them might be 5 volts. You can get these on eBay, same with these. Okay, make sure that's disconnected, and because that's disconnected you will need to provide external power. Okay, now the only place that you provide external power to this is as you would connecting a servo. Okay, you've got your negative, positive and signal there. This one doesn't have a signal. This is 5 volts coming from an ESC, and I can plug it into any one of these to provide power to my unit. Okay, now plug your cable into your USBasp programmer as well. I'll just unpower this for now. Now the other thing you want to do is figure out where this plug goes on the 6-pin header here. Now I've taken the time previously to label these, okay? Ground, MOSI, VCC, reset and serial clock on the back, okay? And they match up with these values on here, okay? So you can use a multimeter and put them to these points to figure out which one's which. At least put the ground one on there, okay? And then on the board, you need to figure out which pin is ground. This one up the top right corner here, and because I've labelled this, it's going to sit on there like so. Don't take my word for it that it's going to go across like this, but in this case the wires go across this way. If you're not, make sure you check it first. Always good to check it first. Next thing you need to do is plug your programmer into your USB, making sure this jumper is not connected, like so. You should have a light come on there. And now we're ready to program via the USBasp. Back over here, if you're already using the USBasp programmer, if you've been using it previously, you should be familiar and know that you have to download the drivers for it. That's if you're on Windows. If you're on Mac or Linux, you don't need drivers for it. But if you're on Windows, you have to go to this website here, official.de, and download the drivers. They're down there. There's another README there as well. So read the README first, okay? But I'm not going to go over the details of actually installing that. Back to Arduino. So you're all plugged in. You've got power as well, so plug power in. So we have power. That should flash there, so it needs to be powered up. And again, choose all your settings. Now what you need to choose here, you want to go to Tools, Programmer, and choose USBasp. And again, make sure the board is Arduino Pro or Pro Mini 5 volts, 16 megahertz. And then you need to go to the File menu. You can't just use the Upload button here. You need to go to the File menu and use Upload using Programmer. Now the output here is slightly different, but you'll get the same bytes written and verifying, and then it's done. Now, what's the difference, you might ask, programming it with the FTDI programmer or programming it with the USBasp programmer? The difference is, with the USBasp programmer, there's more chance for things to go wrong. So if you interrupt your connection while it's being programmed and stuff, you can potentially mess up what's called the fuses on your chip. Fuses are just settings, basically, but they set how fast the chip runs and all sorts of stuff. And if you mess them up, then it can be quite difficult you need to use another method of programming to reprogram them. So you can potentially brick your board, but I've done it hundreds of times. As long as you're careful, you should be good. And the other difference is what happens with a bootloader. When the board boots up, there's a certain amount of time it'll go to the serial port and say, does anyone want to send me any more information so I can reload my own firmware? And it spends a little bit of time doing that, and then it will go into normal operation. Now if you program it directly with USBasp programmer, it will start up just a little bit quicker. You might not notice the difference, but that'll happen. Like, it'll start up a little bit quicker. And also another good reason to have the USBasp programmer is if you want to burn the bootloader as well. When I got this one, it had a corrupt bootloader on it, and I couldn't use the FTDI programmer to program it. So what I had to do, I'll just do it quickly here, it's really easy. You select your board, again 5 volt Arduino Pro Mini, 5 volt 16 megahertz.
you select your programmer, USBasp, and then you go here and click on this Burn Bootloader. Might as well do that. It doesn't give you a lot of feedback. All you see is this may take a minute, so be patient. Just wait for it and it'll program the bootloader, and then you can go ahead and start programming it with the FTDI programmer again. But you can do it all with USBasp if you want. As you can see there, that's still going. There's actually, I think it goes through and wipes everything on the that's in the flash memory on there as well. There we go, done. And we got verifying 1 bytes of lock verified. Okay, so that's my bootloader redone. And if you do that, you will need to reprogram it with your FTDI programmer. Okay, so they're the 2 methods of programming it. Okay, there you go. I hope I've covered everything. It's not the easiest. Maybe our friend Lazy Zero will put the OpenLRSng firmware into his multi-copter flash tool one day. Make it easy for everyone, but this is a proper way to do it. Gives you the most updated firmware and all that sort of thing. So, cheers. Thanks for watching.